Hello everyone. The title of this video is Solve a Rational Equation for a Specific Variable. So in this video, going over many examples in which we're given an equation that has multiple variables, multiple letters, and there are also fractions, rational expressions in the equation. And we'll be asked to solve for one of the variables. Now, each of the examples in this video are taken from a free online textbook at openstax.org. This book is their Intermediate Algebra 2nd edition. I'm in section 7.4, titled Solve Rational Equations. And I'm going to be doing exercises under this heading, Solve a Rational Equation for a Specific Variable. And these are exercises 235 to 250. Alright, that'd be 16 examples I'll be doing in this video. Example 1 will be exercise 235. Example 2 will be 236, and so on, right, all the way until example 16, which will be exercise 250. I will have timestamps for each of the examples in the description of the video, so you can bounce around and look at particular examples if you wish instead of all of them. I'm not expecting you to watch all of them, just enough to where you can understand the material. Alright, and also if whenever a new example comes up in the video, I'd recommend pausing the video and trying to do the problem yourself first before watching me do it. Because if you're just watching me do it and not doing any work yourself, you're probably not going to learn much of anything. Alright, and then after you do it, then go and watch me do it and compare your work to mine and see if you got it correct or incorrect and where could improvements be made, and you can get a grasp as to how well you're holding on or learning the material. Alright. So before I get started, each one of these equations has some sort of fraction, right, or rational expression in it. And we're going to be solving these equations the same way we've been solving other rational equations. Right, I put out a video previously on solving rational equations with a single variable. And I'll be following these steps. These steps presented in the in section 7.4 of this text. So solving equations with rational expressions. So first thing I will do is factor all the denominators completely. Now for these examples with the multiple variables, I may remember to do this, but I may not. Noting values of the variables that would make any denominator 0. I'll try to remember to do this, but so I'm going to factor all the denominators completely, then find the least common denominator of all the denominators in the equation, right, the LCD. And we're going to clear fractions, right, clear denominators away by multiplying both sides of the equation by the LCD. That should leave you with a polynomial equation, and you solve the resulting polynomial equation and check to see, is this solution you found, or are these solutions you found working back in the original equation, right? You should always go back to the original statement to check your answers. Alright, so bringing up the first example. So example 1 here. So again, we're asked to solve each equation for the specified variable. Right? So this is c divided by r equals 2 times pi. Hopefully you recall that pi is not a variable when you see this symbol. Right? It's a number. It's 3.14159 dot dot dot. It's one of those irrational numbers with the symbol that represents it. But there are two variables, right? C and R. Now there's only one denominator here, R. And like I said, I'll try to remember to do this. So it's clear that the value of R, right, can't be 0. Right, because if R were 0, you'd have a denominator of 0 here. And that's not good, right? Denominators of 0 are bad. Can't divide by 0. That's undefined. Now, since that's the only denominator showing up here and it's already completely factored, I mean, the LCD then, and I'm assuming here that you know how to factor polynomials and you know how to find the least common denominator of fractions. Right? That is also something that has been previously discussed if you've been following my videos and following along in this particular OpenStax text. But the least common denominator would just be that R. So I multiply both sides. C over R. Right, I'm multiplying that side by the LCD times R. Right, equals, and then the other side, 2 times pi. I'm also multiplying that by R. Right. And again, our eventual goal here is to solve for R. We're asked to solve this equation for R. So I want to get R alone, right, equals, and then some expression without R. Right, so the whole reason we multiply both sides by the LCD is so all the denominators go away. Right, all the denominators should cancel. Right, the LCD and every denominator should have common factors that will cancel. So you see this on the left here, R in the numerator, R in the denominator. So R's cancel, leaving me with C. And then over here, 2 times pi times R is just 2 times pi times R. But remember, I want R alone. And like I said, I'll write this out. If I want to solve for R, that means we want R equals, and then some expression without R. Right, some expression that doesn't have R on the other side. Well, here I have 2 times pi times R. Right, all the terms with R are on the right side. Terms without R, which is just this C, are on the left side. And yeah, so just get R alone here. Take this coefficient of 2 pi and divide by 2 pi on both sides. Alright, so when all is said and done, I'll just switch sides here. The 2's cancel, pi's cancel, you get R equals, and then the other side, nothing's cancel, and this is C divided by 2 pi. And there's our final result, right? R is solved for. R is alone on one side, and then there's an expression without R on the other. Okay. Now, because R can't be 0, that means the value of this expression can't be 0 either, right? Because this is what R is being replaced with. And if C divided by 2 pi can't be 0, that means C also can't be 0. Right? Because if C were 0, then R would be 0. And R can't be 0. I hope that makes sense. Again, I don't expect you to be able to do this all the time. when there was just a single variable, it was a lot easier. But with these equations with multiple variables, I'll be just satisfied with just solving for a particular variable. So now the check. All right, don't forget to check your solutions. All right, you should always be checking your solutions, and I'll put a little check mark next to that to remind you to check. Well, I'll also write the word check here on the next page. So replace r with this c over 2 pi back in the original equation, and I'd have the following: c divided by, and then I'm replacing r in the denominator by this c over 2 pi, and see if that's actually equal to 2 pi. Well, the left side, you have c divided by c over 2 pi. That's the same thing as c times 2 pi over c. Remember how you can write division problems as multiplication problems. Right? Dividing by something is the same as multiplying by the reciprocal. And then you see the c's are canceling here. And you get 2 pi on the left equals 2 pi on the right. Good. Right. This is indeed the solution in r, the solution for for r in this equation. R equals c over 2 pi. All right, and this will be the only example I do this for, but just know that you should be testing your solutions when you're done solving. Okay, example 2, pretty similar. Just separate these here. So we're given this formula, this equation with 3 variables. We have I divided by r equals p. And we're asked to solve for r again. So I want to get r all by itself on one side, and an expression without r on the other. Alright, so once again, the LCD here is just r. Right, that's the only denominator. So I'm going to multiply the original, I'm going to multiply both sides of the equation by this LCD. Whole reason for doing that is so we clear denominators away. Right now the left side is just I, because the r is canceled, and the right side is p times r, right, or just pr. Right. And now I have all the terms with r on one side, all the terms without r on the other side, and now I would just like to get r alone by doing some division. Right. So I would divide both sides by p. Right. Same thing over here. And doing that, p over p, the p's cancel. I'm left with r equals I divided by p. And there you go. And there is this equation when you solve for r. You get r alone on one side, and an expression without r on the other. And then once again, you can state values that the variables can't be, right? If you looked at the original equation, r was in the denominator, so r can't be 0. And then kind of like in example 1, if r can't be 0 and r is equal to I over p, then I can't be 0 either, because if I were 0, r would be 0, and that's bad. And then looking at the final statement too, you get p in the denominator, so p can also not be 0. Alright, so none of these values can be 0 throughout this problem. When you're talking about the solutions. Alright, again, I'm not going to do this anymore. Okay, you can figure out what values the variables can't take throughout the process of a problem. I'll just solve these equations for the specified variable. All right, and then again, don't forget to check the solution. Replace r with the with I over p, and then you'd see the i's would cancel after multiplying by the reciprocal, and you get p equals p back in the original statement. It would be true. Okay. So again, I'm following the same steps every time. All right, so number 3. We have v plus 3 divided by w minus 1 equals 1/2. So both denominators are already completely factored. Can't factor them any further. So the LCD should be easy to state. Right? It's just the product of these two denominators, 2 times the quantity w minus 1. Alright, so I'm taking both sides and multiplying both sides by this LCD. So there's the left side times the LCD, and the same thing with the right side. 1/2, taking that fraction times the LCD, 2 times the quantity w minus 1. And then you see again the denominators canceling. On the left side, w minus 1 is a common factor, they cancel, and I'm left with 2 times the quantity v plus 3, right, because you got 2 left over, and then the entire numerator, right? Don't just write 2v plus 3, it's 2 times the quantity, the whole numerator, v plus 3. And on the right side, 2's would cancel. I'm left with just 1 times w minus 1, but that's just w minus 1, right? There's no need for parentheses there because you're multiplying by 1. And yeah, and keep in mind here, right? I'm asked to solve this equation for w. Right. Now I'll simplify both sides first, and then we can easily get w alone by adding 1. Right. This left side, after distributing the 2, would be 2v plus 6. Then I have equals w minus 1. And again, we want to get w alone. Well, the only term with w is on the right side, so just get rid of this other term, this negative 1 that doesn't have w, again by adding 1 to both sides, and I get the following. One of the sides has w equals, the other side would be 2v plus 7. Okay, there you go. There's this equation solved for w. And once again, replace w with this expression and see that the original equation is a true statement. And it should be, if you're doing everything correctly. But I leave that to you to check. Alright. Example 4 is pretty similar to example 3. And once again, the denominators, you could factor out a negative 1 from this if you wanted, but I'll leave it the way it is. And the denominators are factored completely, I'd say. And we're solving for y. Right? But first thing in all these equations with fractions is to clear them away by multiplying by the LCD. Right, so the LCD is just the product of these two denominators, 3 times the quantity 2 minus y. Right, so I'm just going to write it here. So I take the whole left side, multiply it by 3 times the quantity 2 minus y. The entire right side, right, just that one fraction, times the LCD, right, times 3 times the quantity 2 minus y. The left side, the 2 minus y's would cancel, leaving me with 3 times the quantity x plus 5. equals, on the right side, the 3's would cancel, leaving me with 4 times the quantity 2 minus y. Okay. Then I'll simplify the sides, and again, our goal here, keep in mind the goal is to get y alone. So distributing the 3 on the left, distributing the 4 on the right, we have 3x plus 15 equals 8 minus 4y. And then to get y alone, right, first I would subtract 8 from both sides, right? Let's just take this over here now, sorry. So the left side would be 3x plus 7 equals, and then when I subtract 8, then you have negative 4y left. And to get y by itself, I would then divide by negative 4. Don't forget you're doing it to the entire side. So on one side I have y equals, and then the other side, now there's a bunch of different ways to write this. You could write the way it looks right there, say 3x plus 7 in the numerator, divided by negative 4 in the denominator. Absolutely nothing wrong with that. There's the equation solved for y. But you could also, since one of these has a factor of negative 1, you could pull that minus out front. Say, put the negative 1 out in front of the fraction, and then you'd have 3x plus 7, plus 7 in the numerator still, and then pulling that negative 1 out front gives you just 4 in the denominator. Same thing there. Or you could have taken, remember when the numerator has multiple terms, you can divide each term by the denominator. Right? Not the other way around though. Right? If the denominator has multiple terms, you can't do anything with that. But if the numerator has multiple terms, you can rewrite it as a sum or a difference of fractions by dividing each term in the numerator by the denominator. So I could write this as 3x divided by negative 4, which is negative 3/4 x, plus 7 divided by negative 4, which would be minus 7/4. Right, and all these, right, every single one of them, is perfectly valid. Right, this, or this, or this. And you could even put that factor of negative 1 in the numerator and make it negative 3x minus 7 in the numerator. There's lots of different ways to write this, but each one is equally valid. And so the equation solved for y. Alright, and again, I'll leave it to you to check. Replace y with one of these expressions here and see that you get a true statement back in the original equation. Okay, same steps, right? Same steps every time. Example 5. A equals, b plus 3 over divided by c minus 2. And we're asked to solve for c, right? So I eventually want c equals, and then an expression without c. Alright, so again here there's only one denominator, and so the LCD is just c minus 2. Right. So I'm taking the left side and multiplying by the quantity c minus 2. Same thing with the right side, right, b plus 3 over c minus 2. This is getting multiplied by the LCD c minus 2, the quantity c minus 2. Alright, now on the left side, this is AC minus 2A. If you decide to distribute the A, you don't really have to, but I'm going to stay consistent. And on the right side, you got the c minus 2's canceling, left with b plus 3. Right, b plus 3. Right. Now don't forget, I'm trying to solve for c. So and this is a linear equation in C to the first. So I take all the terms without C to with C to one side, without C to the other. So then I'd be adding the 2a to both sides. Right, so now I have on the left side, again, sorry, I'm going to drag this over here. I have on the left side a times C. And now on the right side, I got positive 2a that I added over there, positive b plus b, and then plus 3. And again, I want C alone. Well, once you have all the terms with the variable you want on one side, terms without that variable, then you're going to perform some sort of division. And that would be division by a. And I would divide this side by a, canceling the a, leaving me with C alone, and divide this entire expression on the right side also by a. Do the same thing to both sides. So C equals, this expression here, you can write 2a plus b plus 3 in the numerator divided by a in the denominator. And again, there are multiple ways to write this. Remember, when there are multiple terms in the numerator, you can divide each term by the denominator. Well, 2a over a is just 2 plus, and then you have the rest of it, b plus 3 over a, if you want to leave it that way, or 2 plus b over a plus 3 over a, right? Dividing each term by a. Whatever you want, right? Any of those are totally the same expression, totally valid. So this, or this, or this for C. Alright, so from here on out, I'm just going to write one expression. Alright, and just understand that you can rewrite expressions in multiple equivalent ways and still be fine. And then of course I leave it to you to check, if I replace C with either of these expressions here, check to see that the original equation is a true statement. Alright, so number 6. The LCD is clearly just 2 minus n. That's the only denominator showing up here. So I'm going to multiply both sides by this this LCD. So I have m times the quantity 2 minus n equals, and then I hope you see, I'm just going to do this right now. When you multiply the right side by 2 minus n, the 2 minus n's will cancel, and I'm left with just n. Alright, and then we distribute the m over here. That'd be 2m minus m times n equals n. Alright, and now that both sides are simplified, again, pay attention to what variable we're asked to solve for. We're asked to solve for n. So, I've got a term with n on the left and a term with n on the right. And so first I need to get all the terms with n on the same side. So let me do that by adding mn here to both sides. Alright, so now on the left I have 2m, and on the right I have mn plus n, or n plus mn, whatever you want. Okay. So once all the terms with the variable I want to solve for are on the same side, we can combine them. These are technically like terms in n. They both have n. So you can put them together. This is mn plus 1n, or the quantity m plus 1n. Right? If you combine the coefficients of n, you get a new coefficient of m plus 1. Make sure that's in parentheses. Also, you could have also said, hey, these two terms have a common factor of n, and then factor n out. So now I have 2m equals m plus 1 times n. And then comes the division part, right? Once I get all the terms of the variable on one side, you should be able to solve for that by doing some sort of division. So I'm dividing both sides by this quantity m plus 1, but since it's it's the only factor, I don't need parentheses around it when I divide by it. And there we go, right? The m plus 1's cancel over here, and I'm left with n on the one side, and then the other side we have 2m in the numerator divided by m plus 1 in the denominator. And this can't be split up, right? Remember I said before, if the numerator has multiple terms, you can divide each term by the denominator. If the denominator has multiple terms, you can't do anything, right? This is as simple as that fraction gets. So there we go. And I forgot to put my check marks, right? Don't forget to check the solution. Replace n with this expression, this fraction, in both places that there's an n, and then see if you get a true statement, and you should, right? If everything was done correctly, which I'm not seeing any mistakes on my end, so it should work. But I leave it to you to check. Okay, next example. So again, an equation with multiple variables, p and q, and we're asked to solve for p. Right. Well, the only denominators are p and q. Those are already completely factored. So I can very easily state the LCD. The LCD would just be p times q. So I'm taking the entire left side, right? 1 over p plus 2 over q, multiplying that by the LCD, pq, and this will require distributing, right? Because there are multiple terms, right? There's two fractions being added over there. Equals, and then the other side, 4, also multiplied by the LCD, right? So I'll just have 4pq on that side. Now, once again, the whole reason we're multiplying by the LCD is so all the denominators cancel. When you multiply pq times 1 over p, the p's would cancel, and I'd be left with q times 1, which is just q. Plus, and then 2 over q times the LCD, the q's would cancel, and I'd be left with p times 2, so 2p. And then on the other side, 4pq. Alright, don't forget we're solving for p. So I'd like to get all the terms with p as a factor on their own side. Well, there's a term with p on the left, there's a term with p on the right. If I just subtract 2p here, right, subtract 2p from both sides, we'll get the following. The left side will have q, there's no term with p over there, and the right side would have all the terms with p as a factor, 4pq minus 2p. And then, as in the previous example, right, see this has a p, this has a p, every term on this side has p. So we can factor p out if you want. In fact, you could factor 2p out, but I want just p alone though. So I factor out p, and if I do that, what's left over, what the other factor on this side would be 4q minus 2. And then to get p alone, again, after you get all the terms with the variable on one side of these, linear equations, then you should have to just do some sort, do some maybe factoring and then division, right? I'm dividing both sides by this 4q minus 2 factor. Same thing over here. Alright, so then we have, on the one side we'd have p equals, and the other side we have, q in the numerator, 4q minus 2 in the denominator. And you could factor a 2 out of this, but I wouldn't see any common factors that in the numerator and denominator. Right, that's as simple as that fraction is going to get. And once again, when the denominator has multiple terms, you can't divide the numerator by each of them, right? It's not like when the numerator has multiple terms, you can divide by the denominator, divide each term by the denominator. But when the denominator has multiple terms, you do nothing. Just leave it. All right, and try simplifying the fraction. Factor the numerator, factor the denominator, cancel any common factors. But I don't see any common factors here. And again, don't forget to check. Replace p with this expression, and it should work. The original statement, the original equation should end up being a true statement. Pardon me. Alright, example 8 is very similar. 3 over s plus 1 over t equals 2. And keep in mind what we're trying to solve for, right? We're solving for s. Once again, the LCD is simple, right? The least common denominator here would just be s times t. So I'm taking the whole left side, multiplying by st. We'll be distributing, right? 2 terms over there. And then the right side, we're multiplying by st as well, so that'll just be 2st. On the left side, when I multiply 3 over s by st, the s's would cancel. I'd be left with 3t, 3 times t. Then with 1 over t times st, the t's would cancel. I'd be left with 1 times s. Right? And then on the other side, we have 2st. Alright, and then again, I'm trying to solve for s, so get all the terms that have s as a factor to one side. Well, this term on the right side has s as a factor. This term has s, but it's on the left side, so I'm going to take it over, and that'll be it. That should do it. So I have 3t equals, and then we have the 2st still over here on the right side. And then I would have subtracted s, right? So you got minus s. And then just like the previous couple examples, I got all the terms now with s on its own side. So all these terms have s as a common factor. I'll factor that out. Pull out s, and then what would be left over would be 2t minus 1. And then I would, to get s alone like I want, right, we're solving for s, I would then divide by this 2t minus 1. So we'd end up with s on one side, and then the other side would have 3t divided by 2t minus 1. And there you go, there's the equation solved for s. 3t over 2t minus 1. And once again, check it. Replace s back in the original equation. Replace s, again, before I did all the writing here, the way it originally looked, replace s with this expression, and should be making that original statement a true statement. But I leave it to you to check. Alright, example 9. Right. All very, very similar stuff. We have, v and w are the variables. We're asked to solve for w. Now, this time there's a denominator of v and w and 5. All those denominators are totally factored. So the LCD should be easy to state, right? The LCD would just be 5 times v times w. So I'm going to multiply each term on the left side by 5vw. Distributing over there. Same thing on the right side, multiplying by the LCD 5vw. Alright, now on the left side, when you take that first fraction, 2 over v times 5vw, the v's would cancel, and I'd be left with 5w times 2, which would be 10w, plus 1/5 times 5pw, the 5's would cancel, and I'd be left with vw, v times w. And on the right side, the w's would cancel. I'd be left with 5v times 3, or 15v. Alright, now remember, we're solving for w. Now look, this is already nicely set up. Every term on the left has a factor of w, and every term on the right, the 15v, doesn't have a factor of w. So it's already set up the way I wish. And as I've done the previous examples, right, every term on this side has w as a factor. So I can factor that out, pull out w, and if I remove the factor of w from each term, you're left with 10 plus v, or v plus 10. Okay, 10 plus v is the same as v plus 10, okay? You can switch the order of addition. And then this is equal, to 15v. And then to get w alone, I divide by this v plus 10. So, taking this over here, so w would be equal to 15v divided by v plus 10, or 10 plus v. And again, when the denominator has multiple terms, you're not dividing by the numerator. You're not dividing each term of the denominator by the numerator. That stays the way it is. All right, so this is as simple as that gets, and we have solved for w. And again, don't forget to check, replace w with this expression, and see that both, and do a check that the equation is a true statement. Alright, so again, very similar stuff. I'm doing the same steps every single time. First, factor the denominators completely, example 10. X, 3, and y are already completely factored. So the LCD should be easy to state. It would just be 3 times x times y, right? 3xy. Keep in mind that we're solving for y here, right? I want y alone, y equals. Alright, then multiplying the whole left side by the LCD, right, by 3xy, and that'll involve distributing because there are multiple terms. And doing the same thing to the right side, multiplying by the LCD, the 3xy. Now when I multiply this first fraction by the LCD, the x's cancel. I'm left with 3y times 6. That'd be 18y. Plus, then 2/3 times 3xy. The 3's would cancel, and I'm left with 2 times xy. Equals, and then on the right side, the y's cancel, and I'd have 1 times 3x, or just 3x left over. Great. Alright, so now all the denominators are cleared. We're solving for y, and it's already set up where both the terms with y as a factor are on the same side, and all the terms without y as a factor are on the other side. So I can, both of these have y as a factor, so I can pull y out, and if I factor out y, what would be left over would be 18 plus 2x, or 2x plus 18. I like throwing variable terms first, usually. Now you could also factor out a 2, but remember I want y alone. Right, so I'd rather not put 2 next to the y. And then we have equals, 3 times x. And then to get y alone, I would divide both sides by this factor of 2x plus 18. So after doing that, we'd have y on the left, or y on one side. On the other side, it'd be 3x over the 2x plus 18. And that is, again, you could factor a 2 out, but there's no factor of 2 in the numerator, so like this is as simple as it gets, that fraction. Alright, and check it. Right? Don't forget to check it. Replace y back in the original statement, right, before I did all the writing here. Replace y with this expression, and simplify both sides, and you should see that, you know, both sides will give you the same value, the same expression. It'll be a true statement. All right. Example 11. Again, all the same steps. Here I have variables m and n. We're asked to solve for n. N minus 2, 5, right? The denominators are already completely factored. So the LCD is very simple. It's just the product of those two, 5 times the quantity n minus 2. Alright, so I'm multiplying the left side, this fraction, by 5 times the quantity n minus 2, the LCD. Right side, the 4/5, also multiplying by 5 times the quantity n minus 2. On the left side, the n minus 2's would cancel, and I'd be left with 5 times the entire numerator, right? So the quantity, m plus 3. Then on the right side, the 5's would cancel, and I have 4 times the quantity, n minus 2. Right. And then in distributing and simplifying both sides a little bit, we have 5m plus 15 on the left equals 4n minus 8 on the right. And don't forget, we're solving for n. So I got, the only term with n is this 4 times n on the right side. So first I'd be adding 8. I'd add 8 to both sides. And then again, I'm just going to switch sides so that the n's are on the left. So we'd have 4n on one side, right? And then adding 8 gives me 5m plus 23, 15 plus 8 on the other. And then I would divide by 4. Right? So n would be equal to 5m plus 23 in the numerator divided by 4 in the denominator. Right, and once again, this is a case like much earlier where the numerator has multiple terms. When the numerator has multiple terms, you could split it up. Take this as 5m over 4, or 5/4 times m, plus, and then 23/4. So this is the same expression. But whatever you choose is correct. They're both correct. Right? So this one or this one. Right? I'll put this in a little thing here, right? Or this. This is equally valid. Right? And again, check it. Replace n back in the original expression with this statement here, with this expression, the 5m plus 23 over 4, and simplify both sides and see, do you get the same, is the left side the same as the right side? What do you get? 4/5 equals 4/5, and you should. Okay. All right, now in example 12. All right, same stuff. All right, same steps. Now there's only one denominator here, 3 minus t. All right, there's variables s, r, and t, but only one denominator. So that will be the LCD then. 3 minus t. Now if you want to write that as negative t plus 3, that's the same thing. And keep in mind that I'm solving for t. Alright, so on the left side, so I'm just going to write times LCD from here on out. So you're multiplying both sides by this 3 minus t quantity. So on the left side, nothing would cancel. You have r times the quantity, 3 minus t. 3 minus t. Sorry about that. Then on the right side, s over 3 minus t times 3 minus t. The 3 minus t's would cancel, leaving me with s. Alright, now you can simplify the left side here, distributing the r, getting rid of the parentheses. This would be 3r minus, and then r times t. equals, s. All right, and then get all the terms, with t on one side and without t on the other. Now, I personally like having positive coefficients on the variables, that I'm trying to solve for. So you see how the only term with t is this minus rt. So I'm going to add that to the other side, make it plus rt. And then the term with t will be on the right, and then I want to get rid of this term without t on the right, this s, so I will also subtract s from both sides. So that leaves me with, on the left side, I'm just going to bring this over here, 3r minus s equals, and then rt, and I'll have r times t on the right. Right. And now to get t alone, I would just simply divide both sides by r. So on the one side I'll have t alone equals, and then on the other side we'll have 3r minus s in the numerator, then divided by r in the denominator. Which again, this is totally fine, but you can rewrite this if you wish, right? The numerator has multiple terms, and if that's the case, you can divide each term in the numerator by the denominator. 3r divided by r would be 3 minus, and then s over r. Right? This is equally valid. Right? Equally valid expression. So there's t solved for. You could also have t. You could have also t equals this expression too. And then check it, right? Don't forget to check your solutions. Replace t with this expression or this expression back in the original equation and see if it ends up being a true statement. And it should, if I did everything correctly, which looking at it again, I did. Right. Great. Example 13. Again, the same steps. Now this is, again, pretty simple. The examples 13 and 14 are very similar. Almost exactly the same as examples 1 and 2. You want to go back and look at those. E divided by c equals m squared. Solving for c. Now here the LCD is just c, right, the only denominator that's showing up. So I'm multiplying the fraction on the left by c and multiplying the expression on the right by c. Left side, c's would cancel. I'd have e equals, and then the right side, m squared times c. And I know they're trying to trip you up here, saying, hey, it should be e equals mc squared, not m squared c. It doesn't matter. We're not. This isn't a physics problem, all right? So e equals m squared c is correct for this problem, and you don't have any, these variables don't have any meaning at the moment. And then solving for c, I already have the only term with c on the right side. So to get c alone, I would simply divide by m squared. So we'd have c alone on one side equals, and then on the other side, e divided by m squared. And that's it. There's that equation solved for c. And don't forget to check. Right? I'll leave it to you. Replace c in the original expression, the original equation, with e over m squared, and you'll see m squared equals m squared at the end. It is true. This does work. All right. Example 14. Again, very, very simple one. The only denominator. We're solving for capital T here, and that's the only denominator. So that is the LCD, right? This capital T. Multiply both sides by the capital T. Right? Multiply both sides by the LCD. left side, the t's will cancel. You'll have just r equals, on the right side you got w times t. And I wish to get, again, t alone, so I'm now dividing by w. Divide by w, divide by w. So on the right side, but I'm going to put on the left, is t alone. I'm just switching sides here. Equals, and then r divided by w on the other side. And there we go. T is solved for. All right, t equals, and then some expression without t. And don't forget to check. All right, go back to the original equation, right, the way it originally looked, like that, and replace t with r over w, and you'll end up with w equals w. It will make it true. I got one final page here, two more examples. Okay, example 15. Again, pretty simple. The denominators are x, y, and 4, which you could factor to 2 squared, but there's no other numbers in the denominator, so I'll leave it as 4. And I'm hoping it's obvious again that the LCD would be 4xy. Right, so I'm going to take everything on the left side, times the LCD, right, times 4xy. Same thing with the right side, multiply by the LCD, right, by 4xy. And let's see what we get. First fraction, x's would cancel, and I'd have 4y times 3 left over, so 12y. Minus second fraction over here, second term. The y's would cancel. I'd be left with 4x times 5, or 20x. Equals, and then the 4's would cancel on this side, and you'd be left with 1 times xy, or just xy. And keep in mind, right, we're solving for y. So I am going to subtract 12y, giving me negative 20x on the left, equals xy minus 12y on the right. That takes every term with y on the one side and every term without y on the other. And then the whole reason for that is so that you can get y alone eventually. See how both of these terms have y as a factor? So I'm going to pull that out, pull out a factor of y, and the remaining factor, the other factor, would be x minus 12. And then to get y alone, I would divide both sides by this x minus 12. So we'd have y alone on one side. After dividing by x minus 12, you'd have y alone on one side equals, and then the other side would be negative 20x in the numerator divided by x minus 12 in the denominator. And this is perfectly valid. Now, if you don't like negative, if you don't like negatives out, you could put the negative out front, negative, and then 20x. This factor of negative 1 up here, put it out in front of the fraction, negative, and the opposite of 20x over x minus 12. You could also take that factor of negative 1 and put it in the denominator. Multiply the denominator by negative 1, and then you'd have 20x in the numerator. And then negative 1 times x minus 12 would be negative x plus 12, or 12 minus x. All three of these are the same thing. And again, if there are multiple ways to write an expression, you only have to do one of them, right? You don't have to do all three of them, or all four of them, or however many different ways to write it there are. Okay. Yeah, so this is it. Y equals, I'll just use this one, negative 20x divided by x minus 12. And once again, check it. Right, don't forget to check back in the original equation. And before I wrote the LCDs, replace y with this expression and see if you get a true statement, and you should. All right. Final example for this video. And it's the same thing every time. Example 16. Asked to solve this equation for A. And we got A, B, and C. I'm asked to solve for A. The denominators here are A and 5. Alright, so already factored, so clearly the LCD is 5A. And then I'll just write times LCD, right? I'm multiplying every single, the C, the 2 over A, the B over 5, I'm multiplying all of these by the LCD, right? Every term on both sides. So the left side, I would just have 5A times C, right? 5 times A times C. And on the right side, this first fraction, 2 over A times 5A, the A's would cancel, right, and I'd be left with 2 times 5, or 10. Plus, then B over 5 times 5A, the 5's would cancel, and I'd be left with B times A, or A times B. Right, same thing. Alright, once again, we're solving for A, so I would like all the terms with A as a factor on one side and all the terms without A as a factor on the other side. Well, let me just, if I can do that by subtracting this AB term from both sides. So now I see 5AC minus AB on one side equals, and then just 10 on the other. So every term with A is on the left here, and every term without A as a factor is on the right. And as you've seen me do in previous examples in this video, all these terms on the left have A as a common factor, so I will pull that out, factor that out. So I have A factored out, and once A is factored out, the other factor would be 5C minus B. And then we have equals 10. And then finally, right, to get A alone, I would have to divide by this 5C minus B factor. So in the end, we have A alone on the left here, and again, dividing the 10 by this quantity, this factor 5C minus B. And that's as simple as that factor gets, so as that fraction gets. So that's it, there you go. So A equals 10 divided by 5C minus B. And once again, last time I'll say this in this video, last example, just check. Make sure you're checking this, go back to the original equation, replace A with this expression, 10 over 5C minus B, and simplify both sides, and you should end up with C equals C. That should work. Alright, but I leave it to you to check. Alright, so again, hopefully you notice that I followed the same steps, right, every single time here. Found the LCD, multiplied both sides by the LCD, right, every term, and then got all the terms with the variable I was solving for on one side, all the terms without that variable on the other. Then on the side with all the terms of the variable I wanted to solve for, I'd factor that variable out and then divide by what was left and get it alone. And I did that for every single example here. So hopefully watching me go through these 16 examples helps you out when you're working on similar problems. Taking rational equations with multiple variables and solving for a specific variable. Thank you very much for watching.